In lab number 10, we'll be implementing a key vault. Now, this key vault can be used to store three kinds of things: encryption keys, certificates, and secrets. Now, in lab 10, the key vault's key will be used to externalize the encryption of a SQL database. Now, generally, any sort of security mechanism that's available in Microsoft SQL Server uh, is does not apply to the SQL DBA, the system administrator. So, in the event where we need to protect some data uh, that should not be made accessible to the SQL DBA, our approach is to let the client. So here's a client program. We want the client program to have the rights to access a key vault. The key vault contains the key to decrypt data that's stored in the SQL database, while the SQL administrator, while the DBA, should not be allowed access to this key vault. Behind the scene, each column of the table will have a randomly generated symmetric operation key. The symmetric key is encrypted and stored in the data dictionary of the given database. In order to decrypt the symmetric key for that column and return the data to its original form, it is the application's responsibility to have access to the key vault, decrypt the symmetric key out of the data dictionary, and decrypt the actual content. As far as database is concerned, every column value would be nothing more than a series of binary data. Now, those bytes are typically not indexed or searchable in any way. There are two mechanisms of which we can encrypt the data: deterministic and non-deterministic. With a deterministic encryption, we can do equal queries because we can predict what the encrypted value is without using an additional salt randomized value. A randomized encryption, unfortunately, once you decide to use randomized encryption, is secure. It's more secure compared to deterministic, but at the same time, you will no longer be able to perform queries that has equality comparison. Now, for this lab, we're going to deploy the VM, get into it, and install SQL Studio and Visual Studio to protect data in the database and have an application using the ADO.NET driver to transparently to encrypt and decrypt the data as it go in and out of the database. So the purpose of this exercise is to secure data from the DBAs. All right, so here we are going to deploy an ARM template. All right, so I'm going to fast forward this. All right, now the deployment is on its way. We're going to put it on the back burner. We're going to create a key vault and ensure the asymmetric decryption key can be stored in that key vault, and also create a credential to use that key vault for decryption purpose. Now, key vault's job is to keep the key without ever revealing it. So with key vault, we define operations against the things we stored in it. Its job is never to reveal the key. All right, so let's go ahead and okay, let's make sure you're in the PowerShell. That's the bash. Alright, so in the moment, once the key vault is created, we will receive the URL to the key vault. So in the meanwhile, I'll take a minute to go to the VM, install Visual Studio and SQL Development Studio. I'm going to fast forward this a little bit. Alright, so you can see the HTTPS location. So all the artifacts that you put in the vault, for example, a key will be internet addressable. So all the operations are REST operations against those keys. Now, a program must be able to obtain an JWT for its identity, and the JWT must assert the claim that's defined in the access policy of the key vault. Okay, so now we are going to take a moment and go to the key vault and define the access policy. All right, so this is our key vault. Gonna need a notepad real quick. Oops, wrong guy. Forgot to write down the key vault URL. Kind of need it. Going to need it. All right, so this is our key vault URL. Now every key vault has only one access policy. So the general rule is make a key vault for one specific purpose. Do not create a key vault for a whole lot of different things. So in this case, we're going to do an always on encrypt against a SQL database. So make sure this key vault is dedicated just for that. All right, so here we can add an access policy. All right, so we're going to choose key, secret, and certificate management. Generally, we would separate the identity that manages the key vault away from the identity that make use of the key vault. So, for example, the C# program that we're going to build should be able to encrypt and decrypt, but it should not be able to recover, backup, restore, because we need clean separation of these responsibilities. But for this lab, we're going to select every single permission there is. All right, and we're going to grant permission to our own user account. So double check this is the account that you use to log in, as we will be using this as the principal to access the key vault. All right, so next we're going to generate a key. All right, so that's a reference to the key, and this is going to add a software key. There we go. All right, so if you get this error, chances are you forget to click the save. Or you didn't, I did. I always forget to click the save. So it's saying we don't see your name on this access policy. All right, so now hopefully that's taking care of that. All right, so now there it is. Now the key vault will remember every key that's ever generated. Okay. Okay, I think I copied the wrong command. That's the one I need to run again to generate the key. How did I mess this up? I should cut this from the video, but I will forget. Alright, so this is going to show us all the keys in the vault. Alright, and you'll notice every key has a name. For example, this key is called My Lab Key. And as time goes on, you may have to rotate the key. Okay, the key vault will remember every key that's ever generated, unless you decide to purge it. So besides the key vault, we can also, besides keys, key vault can also store secret. So in this case, we're going to store this password string as a key vault secret. Unlike keys, secret is meant to be disclosed to authorized parties. So here we're going to create a secret called SQL password, and the secret will be available to people who have access, who are in the access policy to access this secret. All right, so there's that. Okay, so this is the object, okay, that represents the SQL secret, that is the SQL password. All right, so here we're going to do that IE enhanced security bit. And what we want is to download SQL Management Studio. Okay. All right, so this should be pretty self-explanatory. And then get Visual Studio where we add it. And then double-click install both tool into this lab virtual machine that we created through the template. All right, so I'm going to grab the Community Edition. All right, this will take a good 10 minutes to get the whole thing installed. Now with the Visual Studio, we need desktop and mobile. And select the .NET Desktop development. So we're going to be building some Windows forms. Now Visual Studio offers many different type of workload. So for this lab, we're going to install it with .NET Desktop development. All right, so while the installation is under progress, I'm going to minimize this. Now, next step, we are going to create an application principal. Now, this application principal will be the identity of the app that we're going to develop. Part of creating this identity, we need to obtain two pieces of information, which is the application ID followed by the application secret. Presenting these two pieces of info against the Azure AD token issuing point, we will be able to obtain a JWT, proving our identity. This identity will then be added to the access policy to use keys in the key vault we just created. So here we're going to go to app registration, and we're going to give the application we're about to build an identity. All right, so this will be the name of our app. We're not building a web app, so the redirect URI is inconsequential here. All right, so here there will be an application ID that uniquely identifies the application. So we gotta pull that into our notepad here. I'm gonna use it in a bit. It's a GUID. Now, besides application, now remember, human can provide username and password. Application cannot. So the way application can authenticate is via either knowing the secret or being able to present a certificate and the ownership of that certificate's private key prove its identity. So using either method, this is how our application can obtain the JWT representing itself. So this will be essentially just a password for the app. All right, so you get one chance to copy this to the clipboard. Now these are the two pieces of information that can authenticate an app to Azure AD. So next, we want to make sure this app is granted access to our Key Vault. So we're going to go back to the Key Vault policy like we did last time. So here's a Key Vault, and let's go to access policy. Okay, so it looks like we're actually going to do this via PowerShell. Fair enough. Fair enough. All right, so I'm going to copy this. And where's my QID? So this is my application ID. All right, so we set a variable, and let's get our Key Vault name. All right, so this next commandlet is going to allow our application to get wrap key, unwrap key, sign, verify, and list. So these are the operations our application will be allowed to do: wrap and unwrap key. All right. So typically we use wrap and unwrap keys to protect symmetric keys. All right, so that should do it. Do a quick refresh. All right, so you can see the SQL app now has the key permission, which just include wrap, unwrap. All right. So next we're going to create a SQL database, which we are going to encrypt. All right, database name is medical. And a SQL database requires a server to attach the database to, and it has to be globally unique. All right, and we are going to use our hard-coded names for this lab. All right. All right, so it looks like EastUS is not open for our Azure Pass subscription, so we're going to stick to EastUS 2. It's going to be a little bit of travel from our app to our database. All right, so I'm going to go ahead and create this database. All right, so deployment is underway. I'm going to fast forward this a bit. All right, so here I'm at the SQL database. In order for our VM to connect to the database, we need to allow public access, or allow access from the VM. So allow Azure services and resources. I should do it. Okay. Now, if you, yeah, there's that. So go ahead and save that. Now, I just want to quickly find out what is my IP that's assigned to this VM. We're installing Visual Studio and SQL Server Management Studio. So that is the IP address. And make sure that is added. All right. So this allows connection to that SQL Server database. All right. So now I'm going to fire up SQL Server Management Studio that we've just installed. All right, so while waiting for this install to finish, Now that your database is ready, please go to the database, show your database connection string. We will be using ADO.NET as our driver, so make sure that's recorded. Okay. Now, while at it, you gotta change the password to match what we configured, which is that guy right there. Okay, so make sure the connection string is available in your notepad. Alright, so here's a SQL Server Management Studio. We'll use this to connect to our Azure SQL database. Alright, so there are a few ways to connecting to the database engine. Windows authentication if this machine is joined to a Windows AD. SQL Server authentication is what we're going to use for this lab. Other choices, if you have set up Azure Active Directory admin and your machine is Azure AD joined, then you can do integrated sign-on. Okay. Otherwise, you can say, I want to connect to this SQL Server using my Azure account. Okay, and universal with MFA. Now you have to make sure your database is configured to accept Azure AD admins. That should be on the server settings. So go to overview. Click on the server name. Okay, so you're going to have to set a Azure Active Directory admin before you can try to connect to the database using your Azure AD credential. Now we'll skip that in this lab. We have hard-coded SQL Server authentication. Now you can pull out the server name by your connection string. So that is our server. Login. And the password. All right, so now we are able to make the connection. Now we're going to create a table. Call the patient. Now make sure you execute it against the medical database. Don't. I always do make that mistake by accidentally create them in the master database. That's not fun. All right. So now we should be able to expand the database and see the medical, and we should have one table. All right. Now we're going to right click on that and select Encrypt column. And this will bring up Always Encrypted Wizard. All right. So select the column you would like to encrypt. So we're going to encrypt the SSN and birth date. So these two column will not be available to DBA for DBA to see. All right. So you can say for each column, should it be deterministic or it should be randomized. We're going to make SSN deterministic. So I suppose we're going to do a equals query, and birthday is going to be randomized. All right. Now, deterministic should really only be used when every value is going to be different. Otherwise, if you do, for example, a column like US 50 states, it's not going to be hard to group by encrypted value and figure out, well, 90% of the people lives in New York, and this value looks like 90% of the data. So in this case, SSN is unique across every single record. They're perfect for deterministic. Birthday can simply be randomized. All right, next. All right, and we're going to select Azure Key Vault being the key storage. Okay. Remember, the important point to remember is that we don't want a key to be stored in the database itself. So I'm going to sign in as myself. So this account I used to sign in that created a key vault. All right, so it's going to pull up your subscription and it's going to pull up your key vault. Since we only have one, this is it. All right, select next. All right, so we're going to proceed to finish, and we're going to just commit to do it now. It's also possible to generate a PowerShell script and run it later. All right, so it is done. All right, so once it's done, click on close. All right, now we're going to fire Visual Studio to try to build a console app. All right, so now it's loaded up. By the way, if you expand securities, you'll find in the SSMS always encrypted keys. All right, so there is the column master key, auto-generated, column encryption key. All right, so the column master key decrypts column encryption key, and the key vault key protects the column master key. Now you want to make sure that people who needs to decrypt them have access to data dictionary that points to the key vault location. All right, so now in Visual Studio, we're going to create a new project. There will be a console app, sort of like a hello world. All right, the project name matters little. Okay, actually I need to go back because I selected .NET Core, and based on this instruction, I should install console app .NET Framework. Okay, the instruction has .NET Framework 4.7.2, so make sure you do not choose the one that's .NET Core. Okay, so this is the framework version. Click on Create. All right. Now the Lab 10 folder from all files that's downloaded for this lab exercise on GitHub AZ500. In the module 10 folder, you're going to find this program.cs. Just copy everything, Control A, Control V, paste it over. Don't worry about the wiggly line yet. Okay, go to Tools. After you paste it, go to NuGet Package Manager under Tools and open up Package Manager console. We need to install a few packages. The lab instruction will have the 2 install package we need to run, namely the SQL Azure Key Vault Provider and the Microsoft Identity Model.clients.active directory. So these 2 packages, I think it's pretty self-describing. The first package makes sure you have the Key Vault the necessary library to interact with Azure Key Vault for always encrypted. And the second one just helps your application sign in to Azure AD. All right, so there's a couple of things we need to fix up. So while it's installing the package, we need to get the connection string, the client ID, and the client secret. So all of those we copied earlier. So I'm going to take care of that one. All right, so here's the notepad. This is my connection string. It's long, so. All right, next, client ID. Client ID is the GUID. First line here. Client secret. We obtained that when we created the application principal or the app ID. All right, so there you have it. All right, so we're going to give it a spin. So as part of building the connection string, okay, make sure the property colon encryption setting is set to enabled. So it tells the driver to observe the location of the key vault and goes out and fetch the keys in order to retrieve and store data into encrypted columns. All right, so here we go. So it's going to ask you to enter your server password, and this is going to add some sample data for us. Now it's going to come back and say, well, if you enter a valid SSN, so let's give that a try. We're able to query using a where SSN equal. Now I'm going to switch back to SQL Server Management Studio, and I'm going to create a new query. All right, so you'll see that the data that's existed in the database is in binary format. Now, when I made the connection to this database using SSMS, I did not choose to enable the always encrypted option. Okay, so if you do a connection to a database engine, you may want to go to options, always encrypt. Okay, and then select that. Now, if you are authorized for the key vault, then your connection will allow you to see the actual data. Okay. Perhaps we don't have authority for that. Yes, we don't, because we're signing in using I just realized we're signing using SQL Server Authentication. But if we were to use SQL Integrated Authentication, then if we were using Azure Active Directory login, then we could transparently get to that key vault. All right, so I must remind you the idea behind Always Encrypted is that the data that ever lands into SQL for port 1433 is already encrypted. When the SQL Server returns the data, it's just a series of bytes. Okay? And those series of bytes has to be decrypted by the client application. All right, so that's made evident the fact that we can query and find data using equality comparison. And a DBA can look at the data all it wants. Okay, the data would not be accessible. All right. Okay, so it would just, well, I guess we have access to it. There we go. Apparently we are signed in, and it must have stored my Azure credential here at some point. All right, so I'm going to disconnect from here. And use an option to disable always encrypt. All right. Of course, because that was this account that's encrypted. So let's do a refresh. All right. So without the always encrypt, it's not going to supply my Azure AD credential, and that is going to come back encrypted.